So, we're going to get started. This is Bridging the Gap, Lessons in Adversarial Tradecraft. My name is Will Schrader. My handle on Twitter and GitHub is Harmjoy. I am a security researcher and red teamer for the Adaptive Threat Division of Varus Group. We're actually a sponsor. We love this conference. I'm a co-founder and one of the active developers of the Empire PowerShell project, which we will talk about a bit during this presentation. I'm also the founder, one of the co-founders of Power Tools. I wrote like Powerup, PowerView, a lot of the offensive PowerShell tech. And I'm one of the co-founders and authors of the Veil framework. Actually spoke here last year, I think in the same room, on some kind of AV evasion stuff underneath the hood for Veil evasion, in case anyone was here at that talk. I've talked at a few cons. I love BSides conferences. I love interacting with people. And we're going to do like a Q&A out in the hallway if anyone wants to talk about this stuff if we run out of time.
All right. I'm Matt Nelson. This is my first time speaking at a con, so be nice.
Yeah.
Yep. On Twitter, EnigmaOX3. I'm a penetration tester and red teamer for Varus Group's Adaptive Threat Division. I'm also a developer on the PowerShell Empire project, and I love offensive PowerShell. So if you don't use PowerShell, get with it.
So if you guys happen to have a drink and are playing a drinking game, you drink every time we say PowerShell, and I promise you'll stand up before you leave this presentation. So kind of setting the stage. This is what we'll be going over today. I'm going to kind of do some, our definition of kind of a red team philosophy versus a pen test philosophy. And really kind of one of the things that our group tries to embody is kind of bridging this gap between red team tradecraft and kind of shorter time pen test engagements. We'll go over 3 specific subject areas. Push it real good, salt and pepper. We'll go over kind of weak standard images and how we kind of approach those, some of the things we see. We'll go over network and user hygiene. So what we mean by this are things specifically like hunting for specific users on a network, something we do in every single engagement. Most people do on a lot of engagements. There weren't a lot of like hugely specific tools out there to really approach that problem, so we started to write our own. We'll also go over domain trust. I've given a few talks on domain trust with one of our coworkers who's not here today, Justin Warner. We really like Active Directory domain trust, so I will talk all day about this, whether or not we're at a bar or whatever else. So if you guys are interested in that, please talk to me after. And then the second half of the presentation is going to be on the PowerShell Empire project, which is a PowerShell post-exploitation malware agent that kind of links all this stuff together to help us kind of bridge that gap. So we'll go over the kind of RATS 101, all those kind of components, and over some modules. So Matt's going to hate me for this. I totally didn't switch out the slide decks because I told him I was going to troll him during this presentation, during his first time on stage. So invoke troll exploit. It looks like you're trying to learn some hacker cultural references, Matt. Would you like some help with that? Is it yes, no, or I hate you, Will?
I hate you, Will.
Okay. So Matt's a really sharp guy. He's also young, so we've been trying to educate him in a lot of these hacker cultural references. So Matt, do you know what this is? No? Audience? Anybody? Somebody? Come on. Yeah, it's Whopper, man. Come on. No, you have no idea, do you? Okay. So I promise there won't be any more of those during the presentation. Yeah. So kind of setting the stage, pen testing, red teaming, and what we mean by the assume breach mentality. So pen testing, I know probably a lot of people in this room are pen testers. The definition kind of varies how people define a pen test. It could be, a kind of a glorified vuln scan, vulnerability validation, or it could be a multi-person assault for, several weeks. So the definitions between this and red teaming have kind of started to blur over the last few years. Some people kind of use penetration testing almost as a dirty word now, meaning you just rebrand a Nessus report. We don't like to do that. So I kind of view it as a reasonable balance, breadth versus depth. But the key for penetration testing is seeing how many problems you can find in a network. And then potentially, depending on time frame, seeing how far you can get for those particular issues. But the key is, what can you actually find? It's usually focused on finding these issues and not about kind of like training incident responders or something like that, which is kind of how we tend to define red teaming. So this means different things to different people as well. Some people focus heavily on physical ops. Some people do super in-depth social engineering. A lot of people will do custom exploit development, pure network operations, this kind of stuff. We focus on kind of an adversary simulation, pure network operations type approach. So I'll go over the assume breach kind of mentality here in a second. But one of the common themes with this is for red teaming, there tends to be an increased time frame and like a more permissive scope. It also traditionally tends to have a lot more people, a lot more money, depending on the teams that are involved. So assume breach. we really like this phrase, assume breach. It was actually, I don't know if it was coined, but it was used by Microsoft in an Office 365 red teaming white paper, which is an excellent white paper if you guys haven't read it. So, with all these recent major incidents, a lot of companies have started to realize that you're not going to stop bad guys from getting in the front door, right? So move beyond initial exploitation. Try to harden your perimeter and everything like that. But if your threat model involves a nation state, you are not going to stop them from getting in the front door, right? So companies need to start implementing an assume breach way of thinking. I guess this kind of plays into defense in depth, but how do you stop lateral spread? How do you at least detect? How do you shut everything down? How do you detect C2? A lot of these components that people haven't traditionally thought about because they didn't realize that their threat models actually, involve nation states. We also kind of like, doing things like post-breach activities or kind of exercising incident responders along this way. So. Cool.
All right. And that brings us to bridging the gap. So as Will mentioned, pen testing and red teaming kind of have a different methodology. Red teaming has historically been for teams with a lot of people, a lot of money, and a lot of time. Time's kind of the biggest factor. Pen tests normally are like a week or two. You can't really get an advanced adversarial tradecraft in a week or two. So our approach has been to take the advanced tradecraft that has been for the more advanced teams and kind of push that tradecraft down to people that are in crunch timeframes, who have lack of staff, and then who don't have a whole lot of money. And we're PowerShell fanboys, so PowerShell plays a really big role in this.
Cool. We also try to kind of, build and distribute a knowledge base of these tactics. So we give training, we do lots of blog posts, and we're actually a pretty open book in our group. We pretty much give away everything. Anything we figure out, we're able to publish on. All the tools we do, everything is open source. It's all BSD licensed, and it's all on GitHub. So we want to help try to give back to the community as much as we can.
So why do we use PowerShell? PowerShell has kind of been coined as Microsoft's post-exploitation language, which has been mentioned a few times by, it's a really great quote by Chris Campbell. If you haven't checked this stuff out, definitely go check it out. By default, PowerShell is installed on Windows 7 and up, and it has, I don't know how many of you have interacted with PowerShell, but it has full access to the .NET framework. It's a Microsoft signed and trusted binary, so it gets by a lot of application whitelisting solutions. And it has direct access to the Win32 API. So a lot of stuff in the tools that we write interact with the Win32 API pretty frequently. And then it allows us to assemble malicious binaries completely in memory. So a lot of the ops that we do operate completely in memory, and nothing ever touches disk. So it kind of emulates the advanced tradecraft that a lot of the more advanced teams are able to replicate over an extended time frame. Yep. And so it's kind of been referred to as a toy language over the years. A lot of people have kind of written it off because it is a scripting language. A lot of people don't see a scripting language as something that you can write a full malware agent in. And as you can see on the slide there, it's a recent defensive talk where they kind of listed out all of the public PowerShell offensive frameworks. And you can see SET, Veil Framework, Powerup, PowerView, Empire, pretty recent, Nishang, Mesploit, and then Powercat.
This was actually from a defensive conference, Virus Bulletin 2015. So I think a point with this is, while it's been written off for a while, defenders are finally starting to wake up like, oh yeah, this is bad. And guess what? Bad guys have been using it for a long time.
And so all of this has kind of created a weaponization problem. So there's a lot of offensive capability written in PowerShell that's out there, and PowerShell is really sexy. So it lets us do a whole lot of different things. So a lot of people recently have been deving offensive tools in PowerShell. And they've just kind of been scattered all over the place. And people have picked up the scripts, and they don't really fully understand what's going on under the hood. So it's been really hard for some of the penetration testing methodology to adapt kind of how to use PowerShell securely. We've heard a lot of people of running PowerShell scripts directly from GitHub accounts that they don't control. So people can just change the code and they're just running it willy-nilly. So a lot of the existing tech hasn't always been completely straightforward. PowerShell kind of has a learning curve. In a sense, it's a little different than a lot of the other scripting languages, but it's also really, really powerful. So the people that haven't quite adopted PowerShell yet, we're hoping to kind of solve the weaponization problem to make it easy and understandable for them to operate efficiently with the scripting language.
Again, that's kind of the point that Empire was kind of focused on solving, which we'll go over in a bit. So weak standard images, this is the first of the 3 sections we'll go through. You know, a standard image tends to have a lot of issues associated with it, which a lot of companies don't tend to realize. So, but first, hey Matt, there's Clippy again. Sorry, did you know that was Clippy? I don't know. Do you know what Clippy? Okay, you know what Clippy is. Do you happen to know who this is, or who distributed the bumper stickers? Oh, okay.
That's Kevin Mitnick.
Oh, okay. All right. Good job, Matt. Good job. So standard images. Organizations typically utilize some kind of standard-based image for workstations. Sometimes this varies per business unit. Sometimes it's distributed across the entire organization. Very frequently, we've seen in large, you know, Fortune 200, Fortune 500 companies, this can sometimes be contracted out to third parties because the organizations don't actually want to manage it. What people don't seem to realize is that the security of this image matters a whole lot. Is exploitation of this, or if you find some kind of flaw or issue with the initial base image, you might have a way to laterally spread to every single workstation in the entire organization. Well, you guys think like, oh, okay, really, would any company actually have an issue in their, you know, the image on every single workstation in the entire enterprise? I can assure you it happens very frequently. One of the things, you know, kind of a classic prevest method, right? So side note, we don't really like to focus on kernel exploits, and generally we don't really throw exploits almost ever, or at least recently, or, you know, in very rare cases we might throw on. We really like to use misconfigurations. So services are great for misconfigurations. Kind of the old, you know, Pentest 101 10 years ago is, you know, your SC config bin path kind of thing. You know, if the ACLs associated with the service itself are vulnerable, you might be able to reconfigure it. We really don't see that anymore, but very frequently we see the binaries associated with services not being locked down. So if a company deploys something custom, or even things like, I don't know, Cisco VPN in certain versions, they tend to not lock down the permissions for the binary. So if any user can overwrite the binary for a service, you can custom compile whatever you want. You know, it can add a local user, it can do an agent or whatever else. You overwrite the binary and you reboot the machine, and then you can get, you know, code execution, you can add local users and do whatever else. We still see this like a lot more than we should. It's kind of one of our go-tos. Another method, which is pretty cool, is service DLL path hijacking. So there's a search order for DLLs whenever a service or a program starts up. It's going to look, you know, in its current directory. It's going to look and see Windows System 32 and everything else. And there's a path of like six places that it'll tend to look whenever it loads up DLLs that it needs for extra functionality. The last place it's going to look is every folder in a user's, or the system startup path directory. So if you have write access to any folder in the path and you custom compile a DLL, I think it's WLBSCTRL, I always forget it and have to look up the exact name, and you drop that DLL into a particular writable folder, then when that service starts up, it's actually going to load up your malicious logic. So this just works on Windows 7 at the moment. I haven't seen one actually disclosed for Windows 8 or 10. But it's very, very frequent for Windows 7. So if anyone installs like Python or Perl or a lot of these things that do an extra folder that are added to the path, and that folder is not in program files or Windows, you can, 9 times out of 10 we've seen, you're able to actually drop a malicious DLL and prevest. So, but again, you also have to reboot the box, which sucks, but whatever. So we started going through a lot of these common prevest vectors from misconfigurations, and the first red team I was on several years ago, my boss made me examine every single service executable permission by hand. It was super annoying. It's like, well, I guess there's this thing called PowerShell. I should probably automate it, right? You know, it's what it's used for, is for system automation. So Powerup is a tool that I ended up writing, one of the first tools that kind of came out for the Power Tools toolkit. It automates all the common Windows misconfiguration privilege escalation vectors. So it's all separated by function, but if you use the invoke all checks, which is pretty much what we do most of the time, it'll run through every single check on a system and say, okay, there's a misconfigured service, or there's a leftover sysprep, or, you know, kind of the encyclopedia of prevest for misconfiguration. So we always run this. Usually, very frequently, we'll tend to find things unless we've assessed customers multiple times. We also do some manual inspection of kind of the standard image. So any custom software, any custom you know, custom services or anything like that, we'll actually do pretty similar to kind of dynamic malware analysis, to where, you know, check, is it dropping any files? Is it a local password changer binary? Something like that. And I think we're 4 for 4 for going after local password changer binaries that are custom rolled, because no one ever does them right, even if they think they do them right or run them through an obfuscator. So if you have a reverser on your team, it's super, super awesome. So custom internal development is one of the most common root causes of escalation vectors we tend to see in the field. If people dev this custom stuff and roll it out to every single image, they don't actually do security review of it if it's not a cost product. So even if it is a cost product, there's still sometimes stuff that pops up.
Cool. All right, so network and user hygiene. It is very easy to find targets within a network. So in almost every network we enter, we would consider a dirty network. That kind of breaks into two little classes of where you've got a network hygiene, where a sysadmin will throw up a Tomcat or Apache box and not lock it down, leave default creds, whatever you may have. And that kind of provides a really easy point of pivoting if you need to. And then there's user hygiene, which we see more frequently than network hygiene. A lot of old users, people have, people come and go within the environment and they leave user accounts. Unnecessary admin users, so admins that have access to things that they probably shouldn't have access to. Overly delegated groups, and this is a really big one. So nested groups, within PowerView you can kind of break them out and see, and this has kind of opened up a hole in most of the engagements I've been on recently, to where people have administrative or elevated access to parts of the network they shouldn't have because people don't understand that the groups that they're in are also in groups kind of that are nested within each other. So inadvertently they have administrative access to different parts of the network. And then long-running interactive logons. So they'll leave tokens just laying around. So if you're not able to dump passwords or whatever, tokens are a really easy way to just kind of grab and run. If you pop a box that's not rebooted often, or they leave these interactive logon tokens just laying around, it's really easy to hop on there, grab what you need, and just kind of run around. One of the first things that we do when we pop onto a network, especially if it's dirty, is to hunt. So we don't just spray and pray. It's very surgical in the way that we find what interesting users might have access to what we need to get to. We pop the box, Katz, and then do what we want with their credentials or tokens, and then kind of just run around at that. So do you want to talk on PowerView a little bit?
In 20 seconds, PowerView is one of the second tools that was written. It's kind of a network and domain situation awareness tool, which a lot of the next sections will cover.
So InvokeUserHunter is a function within PowerView that we use very, very frequently. And what it does is it allows you to strategically hunt for users that you're interested in a network and where they might have sessions from. So if you've got administrative access to a majority of the workstations and you're interested in a certain user, you can find where that user is logged in, and you can go and you can specifically target them. And what PowerView does, or what InvokeUserHunter does, is it will query Active Directory for all the hosts, and it'll make that as a target list, and it'll do the same for the users of a target group, which, for example, domain admin. So if you're looking for domain admin, you can match that up against a list of computers, and what it'll do is it'll use Win32 API calls, and it will enumerate sessions of the logged on users and then match that up against your target list. So what's really nice about this is you don't need administrative rights to do this. And as you can see here on the graph, this is kind of how it looks on a network, as you've got the attacker box, and it'll get all the computers from the domain controller. And then it'll take that target list that you've given, which could be domain admins, and it will go out and it'll check the sessions for every computer that it received. And one really important thing is that stealth is kind of something of priority. This function does reach out and it touches every single computer, which can be very, very noisy and will probably get you caught given the IR team knows what they're doing.
Well, it depends how many people know of networks that actually monitor SMB communication in that kind of way. There's some, but I don't know.
So there also is a stealth option, which this used to be called Invoke Stealth User Hunter, and given the recent 2.0 rewrite of PowerView, it is now just an option within Invoke User Hunter. And what this takes advantage of is kind of an old red teaming trick. And what this will do is it will query Active Directory for all users, and it'll reach out and it'll extract the home directory, the script path, and the profile path out of the fields for that user. And it'll attempt to identify the likely file servers that exist on the domain. And it'll take that and it will run through and it will check the sessions that are associated with that file server. So what you're able to do is kind of pinpoint where people are logged in from based on the fact that they've got to drive map back to a file share. And it gets you reasonable coverage with a lot less traffic because instead of touching every single computer, you're touching just the domain controller and you're touching just the file server. Now, this is kind of what it looks like on a network. The attacker box gets the user home directories from the domain controller, and then it will query for the sessions for the user group that you're interested in on the file server, and inadvertently, each workstation has a session mapped back to the file server, so with just touching that file server, you're able to determine what workstations, or what users are on what workstation.
One note too is that this is also much faster, so this tends to be kind of our go-to, and if we can't find the results we need, we might run through the more kind of noisy, better coverage option.
And most, if not the very high majority of organizations have terrible, terrible privilege account hygiene, and this makes our job really, really easy because there's often a way to get elevated access that the org doesn't know about due to something like nested groups or group delegation.
So domain trust, or why you shouldn't trust Active Directory. This is my favorite topic ever. But first, hey Matt, do you know, there's Clippy again. Do you know who this is?
I looked through these slides like 10 minutes
I know,
before.
yeah. I swapped them out. Do you know what movie this is from or who these are?
I don't know, that's a pretty bad screenshot.
Yeah, it's Hack the Planet, bro. Come on.
Oh, okay.
So Active Directory Domain Trust 101. Domain trust allows separate Active Directory domains to form interconnected authentication relationships. It essentially just links up the authentication components for 2 domain controllers or a couple domain controllers in different domains. And it allows this authentication traffic to flow between them. So you can do things like put users in one domain into groups in another, or give certain groups access to different resources. A trust allows for the possibility of privileged access between domains, but it doesn't guarantee it. I had to put a little star here because I'm going to go over some of this history stuff for the inner forest here in a few slides. So there's kind of one caveat if you're within a forest boundary. So Active Directory Domain Trust, why does this matter? I remember hearing about trust a few years ago. There really wasn't much information out there. I'm like, okay, there's a trust. What can I actually do with it? So red teams often will compromise accounts or machines in a domain that's trusted by their actual target. So this might be a subsidiary, this might be a dev domain, this might be something else. So this can allow operators to exploit these existing trust relationships and hop through kind of the trust mesh, which will show some options you can actually do for that. So you can either use this for persistence or kind of escalation to actually compromise the entire forest. I've written a whole bunch of stuff, sorry you can't really see it there. These slides will actually be online right after the talk and we'll tweet out at BSides DC. I've got several different posts that kind of walk through in depth on Active Directory Domain Trust. So PowerView has a ton of functionality within it to enumerate and abuse domain and forest trust relationships. So there's these little commandlets for like getnet forest trust, getnet forest domain, all that kind of stuff, the weird, awesome PowerShell naming convention, a verb-noun. But these can do things of saying like, okay, in my current domain, what domains actually have a trust with it? What I think is cool is that if a trust exists, almost all the functions in PowerView, at least the ones that use kind of like the LDAP querying functionality, can utilize a -domain flag. So if there is a trust, you can say, okay, give me all the users or all the groups or all the domain controllers in this foreign kind of trusted domain. And it's super easy, it's just -domain, whatever the domain is. You don't have to remember all the nested LDAP syntax or AD find or whatever else that people have been doing historically. So no more NL test. Hate it. Well, NL test is awesome, but also it's a pain. So mapping the mesh. One of the other things we'll start to do is if an organization has a large number of interconnected Active Directory domains, it kind of forms this kind of mesh component, which I'll show a visualization here in a second. There's a function in PowerView called InvokeMapd domain trust. What this will do is it'll get all the domains that your current domain trust, and it'll go to each one of those and say, give me all of those trust. And it kind of recursively goes throughout the entire mesh and getting every single kind of relationship that it can enumerate. There's also a -LDAP flag, so by default it'll actually try to reach out to the domains. The LDAP querying functionality will actually go out and reflect it through your current domain controller. So even if you're kind of network segmented off, if there is a trust, you'll be able to get the information. And also 6Dub, one of the other authors on the PowerTools project, has a tool called Domain Trust Explorer, which can perform nodal analysis of this outputted data, meaning centrality, shortest path, that type of stuff. But I think the coolest thing is it can generate GraphML output of the raw data from InvokeMapd domain trust. You can then use open source, graphing tools like we use YAD because it's free. There's a walkthrough of this whole thing on some of the blog posts we have. And you can turn what a domain setup looks like into a nice, pretty graph. That's awesome for outbriefs, to where a lot of these organizations actually don't know how the mesh actually works in their organization. So it's these, you see like the directional arrows. So if there's a one-way trust, it'll just be one arrow. If it's bidirectional, there's two. And the colors actually mean something. I usually forget it, but I think red is parent-child, green is external, and blue is cross-link. So we run this on pretty much every engagement in large enterprises, and we can figure out, oh, if we popped out here and we want to get to crown jewels, like how do we kind of hop through this domain authentication component? And again, we often understand an organization's domain kind of trust mesh better than they do by the end of an engagement. We've had clients actually ask us for the raw data and the GraphML and everything. Like, we actually need this for sysadmining because we never had this before. Most places, you inherit networks and then, you add in subsidiaries and you do whatever else, and it's this giant thing. It's a legitimately hard problem to kind of visualize and manage. So the Mimikatz Trustpocalypse, this is thanks to Sean Metcalf, who's actually up here, Pyrotech in the front of the audience, and also Benjamin Delpy, Gentle Kiwi. So the author of Mimikatz and Sean worked out that Mimikatz golden tickets, who I hope most people hopefully are familiar with, they can accept SID histories. What it means is it's like a migration component for Active Directory, to where there's a SID history attribute in these user fields that basically says, oh, you used to be in this group, here's like the SID of the old group. What this means is if you compromise a domain controller in a child domain, somewhere in here, right? So not the forest root, but somewhere in the child domain, you can create a golden ticket that has enterprise admins for the forest root in the SID history. And this can let you compromise the parent domain. So most people don't realize that the domain is not the trust boundary, the forest is the trust boundary. But most places that we've actually assessed, even the admins that have set stuff up, really don't realize that the forest is the trust boundary. So they'll do, like a segmented dev domain or something like that. Well, that's where we won't worry about securing that. We'll have like secure, whatever between it. But that doesn't matter anymore. Because if you compromise any domain admin credentials in the entire forest, you can compromise the entire forest. This really kind of terrified me and blew my mind when I first realized it. It's already changed the way we've operated on the last few engagements. This is only a few months old. But again, domains are not the trust boundary, forests are. So if any domain controller in your entire enterprise is compromised ever, you just have to keep calm and rebuild the entire forest. According to Benjamin Delpy, this is stolen directly from one of his tweets. So, and again, it's really super easy. I've done this in the field, it works. And using Invoke Mimikatz from Joe Bialik that encompasses some of the Mimikatz binaries, you can do all of this while staying off of disk. And if anyone thinks that attackers or adversaries have not already been doing this, then, I don't know what to tell you. So those are kind of the really pretty quick kind of 3 of the cool areas that our group has made specific progress in, or parts of progress over the last couple of years. And now we wanted to bring it all together and talk about Empire. First things first, this tool will not be possible if it was built on the shoulders of giants. It utilizes a lot of work from a lot of other people. We're in no way claiming that we invented all of this. We did not invent Mimikatz or Invoke Mimikatz or anything else. It's the PowerSplate project from Matt Graber, Chris Campbell, and Joe Bialik. Lee Christensen, Tifkin, Carlos Perez, Ben 10, Sean Metcalf, Sub-T, everybody in the offensive PowerShell community has been awesome. They've been an enormous help, and a lot of the functionality you'll see is built on the work of all these awesome guys.
So I don't know how many of you are familiar with Empire, but so what is Empire? Empire is a fully functional post-exploitation agent written completely in PowerShell. So it operates completely in memory. Its kind of goal was to provide a modular framework to be able to integrate some of the offensive tool sets and projects that have kind of come out in the PowerShell community recently. And it's kind of in conjunction with that, it's to help defenders prepare for PowerShell attacks. So a lot of defenders aren't prepared for PowerShell attacks. A lot of people don't know what it looks like on their network. A lot of them don't do command line auditing, so it's really easy to run and operate completely in PowerShell without getting caught. And kind of the goal of the project was to change that, to see how, or to show them how easy it is for somebody to get into a network and operate completely in PowerShell while giving them indicators of compromise to what a PowerShell attack might look like. So Empire has a few methods of execution. It's post-exploitation, so it doesn't throw exploits. If you can run a command on a target, you can launch an Empire agent. So it starts out as a small stager, which is implemented either as just a manual command. You can manually execute it. It's a one-liner encoded command. Or you can export it out as a bat or a macro or .vbs to deliver in a client-side attack. And the listeners, they sit server-side. The server-side is written in Python. And it stores all the configurations in a back-end SQLite database. So it's really easy to track as things come in and as the listeners catch your agents. It's really easy to kind of track the information that's received from those agents.
Cool. And we'll go over the modular components here in a second, but the stagers are actually modularized. So Casey Smith Sub-T submitted like a new one for HTA stuff to us, and it's very easy to just kind of like drag and drop and like customize stuff if you guys have internal tech you want to use. Real quick on the Empire staging process, we thought a lot about this. You know, we messed up certain components. There might have been an RCE that was disclosed to us that we tried to fix, which we did fix. But Empire staging, that little one-liner that Matt described is going to reach out to the control server. It's going to get a little blob of obfuscated text. That text is, that text is going to be a key negotiation stager that has an AES key embedded within it. That AES key is static per server. It's assumed to be recoverable and burned by defenders. So that's not what the security rests on. The client is then going to generate private and public keys and then wrap up some like kind of staging configuration information with that public key and send it back to the server. The server is going to use that public key, encrypt a randomized AES session key and some like epoch and like kind of synchronization components and send it back to the client. The client's going to decrypt it, post some more sysinfo back to the server, and then it's going to finally get the agent. This scheme is called Encrypted Key Exchange. It uses symmetric encryption to exchange asymmetric encryption, which is then used to exchange symmetric encryption. The point with this that I think is cool is it offers perfect forward secrecy. So even if defenders packet capture this entire process, they can't recover the randomized AES key. And every agent has a completely different AES key per box. So even if people memory image a compromised system, they'll get the key for a particular agent, but they won't be able to decrypt the entire mesh. And first, Matt, do you know what this is? It's Clippy Again.
I have no idea what that is. No.
You have no idea what that is? That's a Captain Crunch whistle. Do you happen to know what tone? No? It's 2600, man. No, okay.
Is that like in a cereal box?
Is that in a cereal box? Yes, it was in a cereal box, Matt. It was used for the control of phone systems, his original phone freaking stuff. Okay, so the module categories for Empire. Everything's, again, I mentioned super modular, drag and drop. You don't have to know how to use PowerShell to actually use Empire, which I think is kind of a cool thing. So we have it separated out. We have our code execution, shell code injection. We actually have a way to easily pass sessions to a Cobalt Strike or Metasploit or another control server you have. Keyloggers, screenshots, host management. There's over 100 different modules. One of my favorite is Trollsploit at the bottom. That's an actual set of modules. It does things like change people's backgrounds and also uses, it can play Thunderstruck by opening up a hidden IE window, opening up a video, and then it'll emulate the key press to turn your volume all the way up so they can't actually turn it down, and it'll play Thunderstruck in the background. So, and fun fact, you may be able to task any module to all of your agents at one time. So if you wanted to Thunderstrike all the incident response department, you totally could do that with Empire. And there's a ton of like persistent stuff. Again, a lot of this draws off of like the PowerSploit project. We have WMI persistence, run key stuff. We have alternate data streams. We have a lot of cool stuff. Then all the PowerView and PowerUp functionality is actually encapsulated within it. I think this is the coolest thing with Empire. And again, we're not claiming that we're writing some super awesome advanced undetectable malware. That's not the point. And we didn't do that even if we wanted to claim it was the point. With Empire, you can develop stuff and adapt extremely quickly. So there's a huge amount of PowerShell stuff already out there, like we mentioned. So if you can write functionality in PowerShell, you can drop it in a module, in a custom module, and have that already loaded up for your agents. So there's kind of a metadata container, kind of in the MSF style type thing. So you have your script embedded in it. You have authorship and description, all those types of things. But we also have options for, does this module need administrator privileges? Is it OPSEC safe? So does it drop a file to disk, or does it display something to users? And it will like prompt you, an additional kind of safety check. So we really built this tool to kind of play into the tradecraft that we tend to do for engagements. So we'll go over two of the modules really quickly. If you guys are more interested in Empire, our BSides Las Vegas presentation goes into this stuff a lot more depth, or again, just talk to me outside and I won't stop talking about it. So the coolest module, outside of Mimikatz, of course, is PSInject. So one of the things we were realizing building this agent was, everyone's like, well, okay, I'm going to block down PowerShell.exe, I'm going to throw into app blocker, so therefore I don't have to worry about PowerShell malware anymore, right? There's a lot of admins that tend to think like that. So we realized it'd be really nice to have our PowerShell agent running in processes that are not PowerShell.exe. So how does this work? A few months ago in the spring, Jess and I gave a talk at CarolinaCon called Drilling Deeper with Veil's Power Tools. And in it, Justin released a tool called InvokePSInjector. It wraps up Lee Christensen's or Tifkin's project called Unmanaged PowerShell. What this does, it was a C program that will load up the managed.NET run space in a C program, start a PowerShell object, and then invoke whatever code you want. So Justin transformed this into a reflective DLL and then embedded it all in a PowerShell script. So what this functionality behind the scenes does is it'll use a PowerShell script to inject a DLL into another process, which will load up the .NET run space, and it'll patch in like our little key negotiation stager component, and then load up our agent running in something that's not PowerShell, which I think is pretty cool. So we don't have process migration, but we at least have process injection for the entire agent. This is kind of what it'll look like. We got a nice little welcome to the internet unicorn. But PSInjector, injecting this DLL, which is actually, he termed reflective pick, into another process. It loads up the .NET assembly, kicks off the download cradle, and then we have our agent running in something like LSASS, which actually works, which really surprised me. I was expecting everything to crash. But if you have the entire .NET assembly is loaded up into LSASS, it's probably a pretty big indicator of compromise, because why would you ever possibly do that? We actually go over some defensive stuff in the BSides LV talk. There are a lot of host indicators that Empire will drop. So again, not trying to fool or get by manual defenders. Our big goal would be, let's get by as many kind of automated solutions as we can to push clients to doing, the host memory analysis and actually doing that triage and getting to that point. If you do get to that point, it's a scripting language, so guess what? The script is entirely in memory. If you just do a memory dump of it, you can get the entire agent. It's not trying to hide. There's no obfuscation. And if you do command line on the script block logging in new PowerShell 5, and you turn it all the way up, you're going to get the entire agent, spec'd out to the event logging. To us, we don't view that as a huge, huge problem, because if a client actually correlates all those logs, like, we're trying to train them to get to that point. So at least, we think that's a good thing, personally.
So as it was mentioned before, Empire contains a PowerShell version of Mimikatz, and it's just, it loads in a base64 encoded DLL of Mimikatz. Obviously, thanks to Benjamin Delpy and Joseph Bialik for the implementation. A lot of people use Mimikatz specifically for dumping creds from memory. There's so much more goodness than what a lot of people will realize. You can do things golden tickets, silver tickets, a lot of the pass the hash functionality, skeleton keys, and one of the most recent ones, DC sync, which is nauseatingly amazing. And so when you use Mimikatz within Empire, Empire has an internal credential store. So it'll store hashes and plain text passwords of all the credentials that you dumped. So it'll take the output and it'll parse it and it'll throw it in this database. And you can it'll assign a cred ID to each credential. And then within the modules, you can specify a cred ID and just automatically run that module using that set of credentials. So it makes it really easy to kind of cross-correlate the credentials you have to the modules that you want to use to operate, whether that be lateral spread or whatever you may have. Yep.
So for example, you could use this as like a golden ticket catalog. After you dump a bunch of DCs, you can just go through and it'll pull the SID, you'll pull the domain SID and all the kind of configuration information, and you can just say cred ID, golden ticket, this domain, and then have all your access. So now we're going to do, oh, that was the picture. We're going to do our demo, standard gods versus humans. I promise I didn't change the video, Matt. Okay. So this is about a 10-minute video, and after that, we're pretty much done. So kind of setting the stage with this, we fished a user, they were local admin, and we actually ran bypass UAC. So we had to implement our own bypass UAC purely in PowerShell. Luckily, most of the kind of, the DL hijack functionality and everything was, licensed in Metasploit and everything like that. So we can kind of adapt, the hijack locations for it. So Matt's going to narrate through the rest of the video. That's going to show doing a multi-part domain compromise using Empire entirely. Hopefully you guys can kind of see that. I know yeah, you can probably explain it. Okay.
So yeah, the way that this starts out is you land as a normal user, elevate, dump their creds. As you can see, this is running Mimikatz, and everything's run. The big jobs they run as jobs, so their background. And as you can see here, all the credentials are stored in the credential store, and they're each assigned a cred ID. And you can use that here. So in the situation, we hit a box with DFM logged in, but we see that there are credentials in memory for a user named Corey. And so you can use a module for getting at user, which is in PowerView, to get the information or what groups is Corey user, which we don't know who he is, what he might be a part of. As you can see here, Corey is a workstation admin. So he likely logged in or off to that box to do some sort of maintenance on some random PC that's some unelevated user. So now that we've got what we might consider an elevated user within the network who might have administrative access to all of the workstations, we can kick off a user hunter for that specific user. And it takes a few seconds to run.
So by default, Empire's fully asynchronous, so it's going to be right now it's set to a 5-second callback to get the tasking and get the result.
And so you'll see it's got a session from this specific IP, and that's the user. So when user hunter kicked off, we were looking for users that are in the domain admins group, and we saw that Will is a domain admin, and he had a session from this IP. And so we're able to verify that this Corey user, which we now have creds for, could potentially be a local admin. It's always good to verify before you go and try and pop the box. It's just good tradecraft to make sure that what you're getting ready to hit, you're actually going to be able to hit instead of just going after it willy-nilly.
We'll get the local administrators of a remote machine without needing privilege access for it. So I think it's one of the cooler functions in PowerView. And he's setting the recurse flag, which means any results that come back, any of the results that are groups, it's going to go to Active Directory and get all the members of those groups and recurse all the way down to get you the set of effective users who could administer that machine.
Yep. So we can say that workstation admins is in the local administrator group on that workstation, and it'll list out the users in the workstation admins group, and Corey happens to be that potential user that we've got. So we are now able to laterally move over to that box using WMI, which is amazing. It's our default for lateral movement. It's really clean, it's really safe, it's just a really good way. So as you can see here, you can set the listener, and then you set the computer name to either the host name or the IP. And then you can see we set the cred ID to 4, which is the credential store for the plaintext passwords of Corey.
And you see too that you haven't seen a PowerShell prompt, you haven't had to use the pipeline, you didn't even know that PowerShell is running underneath it.
Yep. You run this and you'll get an agent back from that box that we just determined that we wanted to go and target. And we are running as an elevated user on that box that has a domain admin logged in. And so now, what's really nice is PS will list all of the processes running, and you can filter to what you want to inject. So we've got kind of a list of safe processes to inject into, DWM being one of them. So you can filter for what processes are running with the name DWM by typing PS DWM. So it's really a quick and easy way to pick what process you want to inject into. And you can use PSInject, which is an alias for the PSInject module, set your listener, which is test, and then the process ID. And then if you go ahead and run it, what it'll do is it'll do what Will was talking about previously, invoke PSInject, and it will inject a Empire agent into DWM. And you can see that we've got a process running as Will, which is a domain admin, on that box within DWM. And now, what you'll be able to do is
domain trust.
Yep. So you'll get the domain controllers. It's a good way to verify that you're actually running as domain admin, given whatever may happen on the network. So what domain controllers are defaultly set or exist on the network, and then I don't remember if I'd $C$ed or not. So this will give the output of the name. The way that this is set up is we landed in a child domain, which is dev.lab.local. And then the root domain is just lab.local. And so the whole idea is to hop the trust up from an unelevated user, and then you can see just to verify before you do anything, it's always just good tradecraft to verify that you're actually running as a domain admin. You can $$ the domain controller. And then this is another module. So most of the most frequently used functions in PowerView are in the network situational awareness path within Empire. And then this will get the domain trust that exists. And as you can see, dev.lab.local and lab.local, it's a parent-child, and the trust is bidirectional.
Meaning as part of a forest internally.
Yep. And then this is where things get really scary. So do a user to SID for the actual lab or the root domain.
So he's gathering all the information he needs for DC sync.
Yep. So you'll get the KRB TTG SID. So you'll resolve that account to a SID, which we'll use in DC sync to do evil stuff. And if at any point, if you've got a long-running job, you can type jobs, and it'll list what jobs are running, and then you can kill those jobs if they're taking too long or if you don't need them anymore or for whatever reason. And it's important to note you'll want to cut the 502 off on the SID, because what you'll end up doing is just replacing
You want the actual domain SID,
yeah.
You don't want the full, like, the entire user SID.
And this is DC sync. So we're going to DC sync the child domain controller first.
For DC sync simulates Active Directory domain controller replication protocol, one of the protocols, to where it pretends the local workstation is a DC and goes to another DC and says, hey, please replicate all this information to me, meaning the hash of this user. So you can get hashes from remote DCs without installing an agent or doing code execution on those boxes.
So we'll be able to pull the KRB TTG of that account using DC sync. So as you'll see, and what's nice is when you do this, since it's a function in Mimikatz, it will actually populate the cred store with the credentials, and you'll see that here in a second. And that makes it really easy to use those credentials to throw into the golden ticket module, which we'll be able to see. So as you can see here, cred ID 6 is our KRB TTG hash for labdc2, which is the domain controller for the child domain. And you can set the cred ID to that particular cred.
This is also why we recorded this demo, because there's probably 25 different steps. So
yeah. And you can just do whatever user you want. And set the SID, and then at the end, you'll add -519, which is, I believe, the ending portion of enterprise admins. And that's important because I did this video like 4 times and didn't throw that in, and it never worked, and I was getting really, really, really sad. So,
this is going to set the SID history in the golden ticket to say, hey, this user who doesn't exist used to be an enterprise admin for the entire forest. Please give me access to everything. So, you know, if you're a defensive guy, like getting all the logs and everything for this, like how do you think that would actually look when you're doing some kind of collection? Like that's going to, oh, and then like, yeah, and then run DC sync components.
So let that run.
So this will actually, with Mimikatz, it'll inject the ticket completely into memory. It's not saving the ticket off, so nothing is touching disk at this component at this time.
So you can see that totally an administrator was created for the current session in the dev domain or the child domain. And we can go back to DC sync and then set the domain to the root, and then set the user to the KRB TTG of the root domain, and then execute it. And what this will do is it'll pull out the hash of the KRB TTG of the parent domain or the root domain. And I forgot to highlight it, so I figured I would.
Thank you, Sean, for SID history.
Yes, amazing.
It legitimately blew my mind the first time I heard about it. I was like, what? No, that's not possible. Is that the end of the demo after that?
No, yeah. Well, after here in a second, yeah.
Sure. Cool.
So, you know,
so we were able to compromise the entire forest.
Yep.
From a starting point, lateral spread, escalate, all those kind of components, DC sync, hop up the trust, entirely using PowerShell, staying off a disk, entirely in memory, and not having to worry about that stuff. So, cool. Let's see. Yeah, all right, we have a few minutes left, and that's pretty much it for now. Again, these slides will be online after, tweeted out at BSides DC. Again, everything here is open source. The PowerShell Empire GitHub organization has the Empire project and the Power Tools project. We actually have complete documentation for the Empire project on PowerShellEmpire.com. We spent a lot of time actually speccing out how to use it, how to set everything up, and making a slick interface for it if you're interested in it. Or hit myself up or Matt up, or I don't know if anybody had any questions, either now or you can hit us in the hallway if you'd rather talk after. So that's pretty much it. So thank you guys so much. Really appreciate it. And thank you, Matt, for being a very good sport for me substituting the presentation in at the end. Oh, and we have Empire stickers if anyone wants one after.